So in this question we're looking at angle of elevation and angle of depression. Now both these angles always work from the horizontal. So angle of elevation is the angle you look up through from the horizontal to see, in this case, the top of the cliff. And the angle of depression is the angle you look down through from the horizontal till you see what you're looking at. So here we're told the angle of elevation of the top of the cliff from A is 40 degrees. So from the horizontal here, that means that is 40 degrees. And they want to know what the angle of depression is of B from the top of the cliff. Now remember, it's always from the horizontal. So the angle of depression is this angle. However, because down here it's also horizontal, these are parallel lines. So using the fact that alternate angles on parallel lines are equal, if we can find this angle, then that tells us what the angle of depression is as well. Now before we can find this angle, we need to find the height of the cliff. So we need to find the height h. So to do that, we're going to use the big triangle. They gave us the angle of elevation for a reason. So we know that this angle is 40 degrees, and this distance here is the 150 plus 50, which is 200 meters, and we want to find h. Now, because we've got a right angle, because we can assume that the cliff is at right angles to the sea, we can use sohcahtoa. So from the angle, the side opposite the angle is our O, and this side here is our A, because it's not the hypotenuse. So the one that uses O and A is toa, and because we're trying to find the opposite, it tells us that O equals A times tan of the angle. So in this case, H equals 200 tan theta. So this gives us H is 167.82 meters. Because this wasn't asked specifically, keep it as the unrounded value. And now we're going to use the small triangle to find this angle here, where that's B. So we know now that this is 167.82 and this is 150. So again, we want to find theta. We know O, we know A, so using toa, we know that tan theta equals the opposite over the adjacent. So tan theta equals 167.82 divided by 150. So theta, whenever you're finding an angle, you do the inverse tan. So the inverse tan of that gives you 48.2 degrees. And the angle of depression, because that's from the horizontal and these are both parallel, is equal to theta. So the angle of depression is also 48.2 degrees. Meters. So in this question, it's broken down to us for us in a couple of parts. CD is actually 15 centimeters, and it tells us that ED is 2/3 of AD. And because we know that ED is 12 centimeters, 2/3 of AD equals ED, which is 12. So let's get rid of the thirds, the fraction first, so we'll times both sides by 3. So 2 times AD equals 12 times 3, which is 36. So AD is going to be 36 divided by 2, which is 18 centimetres. So we now know that whole distance here is 18 centimetres. Now the next part of the question asks us to find the area of CED. So it's asking us to find this area. Now because it's a right angle, we can use our normal area for a triangle, which is a half times base times height. So in this case it's going to be a half times 12 times 15. So the area is going to be 90 centimetres squared. Don't forget your units in these questions. Now they're asking us to find the area of ABCE, so they're after this area. Now we could use the area of a trapezium, but it's easier here to find the area of the rectangle, which is 15 times 18, length times width, and then subtract the area of the triangle, which is 90. So this gives us 270 minus 90. So the area is going to be 180. And again, don't forget your units, centimetres squared. But remember, for the area of a triangle, we must have the right angle in there, otherwise we have to use the other area rule.